Okay, we are recording. Ethan, should I give people a little bit more time or should I hop into it?
Go for it.
All right, sounds good.
Reminder to record.
Okay, hello everyone and welcome to the long deck for the Farmlink project. We're going to be going into some more detail of the tool we created, talking about our design process, the technology we used, some of the features we really enjoyed building out, and then some of the specific experiences from our team. So as I mentioned in the short deck, this was our super team throughout the year. I know it sounds cliche, but there can't be a successful team-oriented project without everyone doing their part. And our team was no different this year. Jacob built out the scrape that allowed us to pull data from the USDA. Tabitha developed the pricing tab from scratch. Lucas worked to develop the framework for how our data would be stored and accessed in Firebase, which is our database. Then Alice built out all the transactions tab from start to finish. Amber worked out the development of the wireframes, which helped visualize our ideas and allow the information to be presented in a clear manner. And then lastly, Drew helped to connect the front and back end. And then he also set up the Google Cloud function to allow us to automate the data pull that Jacob worked. So Farmlink was started by a group of college students in March 2020, and they wanted to help the people that were hardest hit by COVID-19. Those students looked at farmers that were dumping milk and plowing under fresh vegetables because demand from restaurants, stadiums, and other food distributors were plummeting at the beginning of the pandemic. And they quickly realized that there was a need for an organization like Farmlink. So moving forward, they plan to become a sustainable organization that fights against food insecurity and food waste even as the pandemic starts to wane. The hope is that Farmlink eventually sets up an infrastructure to, quote, put themselves out of business by connecting excess food with communities that have food shortages. And they're striving for a world where there are no hungry people lining up outside of understocked and underfunded food banks so that at the end of the day, they can render themselves obsolete. So with Farmlink's goal being to maximize the amount of excess produce brought to impoverished communities, they need to seek out the biggest price advantages, which are going to free up more money down the line to purchase more produce. So for this to happen, the Farmlink team needs to have easy access to all of the factors at play in making a smart purchase. So they need to know how the current price of a produce item compares to where it has been or should be, along with what they've paid for produce items at other farms in the past. Under the previous system, it took a market expert to know all of this information off the top of their head. Otherwise, someone would have to spend countless time manually sifting through the USDA website to find what they were looking for. Instead, our tool puts all of those important factors in one place, which means that it doesn't take a market expert to identify market trends and make the corresponding decisions. It allows volunteers to spend less time manually sifting through data and then more time connecting with and reaching out to new farms and food banks. Additionally, the ability to easily see the produce items that Farmlink should target is going to allow them to be more proactive, therefore purchasing more produce than they otherwise could. So to show the impact of this tool, I think it'd be best given via an example and a quick little demo. So we're going to give the example of potatoes. So let's say we wanted to search on potatoes. So you'll quickly see that with potatoes, the South Central and Midwest regions have percent decreases in all categories. And this is a good indicator that Farmlink should take advantage of the surplus in the market and buy from Midwest and South Central potato farmers. On the other hand, if you scroll down, you can see that the price of potatoes in the Northeast is much higher than normal. So it would be smart to avoid buying potatoes from that region for the time being. Another quick note before we move on to the transaction side is with the regions. We decided to nix the Alaska and Hawaii data for a lack of consistent publishing. And then we also didn't pull the nationalized data because some specific regional changes would be a lot more indicative of potential action items than aggregating national data that doesn't necessarily tell the whole story. So back to our example from before. So we know that potatoes are doing really well in the Midwest and the South Central. So looking at the most recent transactions, let's search for potatoes, and we can see that the most recent transaction in the Midwest was from Awesome Farms on April 20th. So let's see what kind of precedent Farmlink has with Awesome Farms. You can quickly see that there's about 6 pages of transactions with Awesome Farms. They're a very common vendor. So what Farmlink can do with this data is they can use a combination of these previous sales and the market changes to make their decision on where to buy in the Midwest. They can either buy again from Awesome Farms, in which case the previous transactions are going to carry a larger weight because there's a lot more precedent to back that off of. Or they could find a new vendor, in which case the price changes are going to play a bigger role because there is no precedent with that farm. Overall, though, this is an example that Farmlink sees often, given that potatoes are one of their most frequently transported produce items. So optimizing this process, especially for potatoes, as much as possible is essential. So here's the tech stack we ended up going with, and I'll go into a bit of detail in the role each technology played, as well as the big decisions that were made for certain technologies. On the back end, we have a Python scrape that goes through the USDA website and pulls the most recent week's produce data from each region and makes calculations of percent changes for each item. This data is then stored in Firebase, which is very important to limiting the querying time on the front end. If we didn't have this storage layer, the Python script would have to pull the necessary data each time the user ran the tool, instead of only pulling from existing data in a database. And then lastly, React is the user-facing layer that takes the data from Firebase and displays it in the visually appealing and readable manner that you just saw in the demo. The data pull and transfer into Firebase is all automated by our Google Cloud function, which has a trigger that runs the script every Monday morning. And then that way, each week, all we need to do is pull the most recent week's data and view the existing Firebase data to make our necessary calculations. In hindsight, out of the whole tech stack, the decision to go with Firebase definitely caused us the most trouble. We were initially planning to use MongoDB over something like MySQL because of its ability to hold nested JSON data, as well as some experience that our team had with MongoDB. But we quickly realized that the free version of Mongo would not allow us to use a Google Cloud function to automate this data transfer, so then we needed to look elsewhere. But fortunately, the Firebase permissions for a free user allowed us to pull all the data we needed, given that we aren't operating with vast Amazon or Facebook levels of data. But for everything else, our decisions were pretty simple, and they were based on a combination of applicability, team experience, and budget. We ended up choosing Google Cloud Functions to trigger our weekly data pull because the smaller amount of data we were pulling on a weekly basis limited this cost to mere pennies on the dollar each month. Python is a language that not only fits perfectly for data analytics, but it's also quite common on the back end of web applications. So when you combine that with the fact that we had a really good amount of experience on the team with Python, it was a no-brainer. As for React, similarly to Python, once we realized we were going to be operating with a web application, it was the most logical solution. I think one of the coolest parts about this project is looking at the wireframes from early on and watching how our ideas and our concepts of the UI changed as we gained more information from Farmlink about what they wanted the final product to look like. Here we have some of Amber's initial drawings of the two tabs, where you can definitely see some elements of the final project, but there are a lot of details we've yet to uncover. From some back and forth between the stakeholders and the rest of the team, then Amber developed some wireframes in a prototyping tool called Figma, which put some more meat and bones onto the original sketches. And you can definitely see some parts of these designs that made it to the final versions, but we realized we'd lose a lot of speed and performance if we needed to render that many images for that many types of produce. Additionally, if the Farmlink team recommended that there really only need to be 3 pricing metrics that we calculated, all of which you just saw in the demo. So we made a few changes and we moved on to this, which, as you can see, looks a lot more like our final product. The transactions tab in particular looks very similar to the final product, besides adding in the search and date range selection functionalities. Then on the pricing tab, from some back and forth between our team and the Farmlink team, we decided that displaying all of the percent changes under each column and then just changing which column would be highlighted would be the best option, because it would allow the user to see the percent changes of each column at the same time while still being able to sort by their column of choice. And then after making those final changes, we reached the final version that you saw in our demo. And looking back on this year, and this is true across all Change++ projects, the designers were a new addition to the teams this year, and I can say without question, there's no way we'd have such a clean UI otherwise. And again, I know I speak for all the other PMs and project members on that as well. So from our overall team strategy perspective, we found out early on that it would be best to divide the team into a front-end team and a back-end team, with Alice and Tabitha heading up the front end and Jacob, Lucas, and Drew on the back end. Something that worked out really well about that method was that the way we divided up tasks meant that by the second half of the project, we all had a really good idea of what the next couple tasks would be. Because we were so familiar with our own progressions within our specific part of the project, it meant we could just make the transitions between tasks that much simpler because we were familiar with the steps it took to get there. To remain on the same page and hold one another accountable, we would also start each meeting by updating one another on our progress from the previous week. And then for handling problems as a group, we would also schedule meetings with specific subgroups of the team. So as an example, we could have a front end or a back end team meeting, which were very helpful for making decisions on technologies to use or working through common issues because we could go more in depth on things that didn't necessarily affect everybody, but still affected enough people where it was important to hammer it out over a call. With the executive board, the primary role for us was an advisory one. Drew brought a fantastic outside perspective to the team when he joined, and his technical experience helped us make much more sound decisions throughout the project lifecycle. Now I'm going to move into some of the features of the app with some specifics as to how we use them and then how they benefit the final product. So on the front end side, we're using a library called Redux to store data for the user while they use the tool. And Redux is essentially a state container, which allows JavaScript and React apps to stay consistent across all of its environments. So as an example from the demo, we wanted to make sure that any searches, sorts, and group selections that a user made, whether it was on the pricing or the transactions tab, are stored and presented so they can see all of those filters at once. We also used a tool called Heroku to allow us to host our website online. We configured Heroku to automatically post any changes we made on our GitHub repository to the actual website, which down the line makes it much simpler to implement potential tweaks that the Farmlink team may want. And this is huge because if there are things that the Farmlink team realizes they would like to add later on, all we need to do is make those changes on our GitHub repository, which I'll get to in a second. And then when we publish it, it's automatically added to the website and the Farmlink team doesn't have to adjust anything. So I think one of the coolest things about Change++ is how unique it is from the classroom. As an example, we worked on a GitHub repository as a team, which has been an invaluable experience. Because in class, we would often use GitHub for individual projects, but doing so on a team in this environment required us to divide up work so that we wouldn't step on one another's toes and cause merge conflicts as we sent everything into the master branch. In class, we're also expected to develop a specific solution with preset technologies, whereas with Change++, we had to develop the scope of the project ourselves, making decisions on the technologies to use and also having to learn those technologies outside of a classroom environment. But lastly, and perhaps the most simply, we had the opportunity to work with a stakeholder to solve a real-world problem, seeing the project through from start to finish. Having such a people-oriented project and so many opportunities for learning and growth made this experience so unique from anything else. And I'm confident that each of us are leaving this project as better software developers, team members, and problem solvers. A shout out to Jacob, Tabitha, Lucas, Alice, Amber, and Drew for making my job as easy as possible this year. And thank you to Farmlink for working with us throughout the project to bring the tool to where it is now. Thank you all for coming to hear our long deck, and I'd love to open it up to questions if y'all have any.